Fractions, they're parts of a whole. Fractions, they're what I know. They're equal pieces.
The key objective I am focusing on for my video is to investigate strategies to solve problems involving addition of fractions with the same denominator. This is at grade 5 level according to OzVals. The prior knowledge students need to be able to add fractions are understanding fractions, equivalent fractions, solve the operations using whole numbers, estimate answers by using whole numbers and benchmarks, an understanding of numeration, place value, and renaming along with the facility with the basic facts. I have decided to use the addition algorithm for adding fractions as a learning activity because students have prior knowledge in using the algorithm with addition and decimals. Therefore, after the addition of decimal fractions, there has been established and numeration for common fractions has been built up. The addition algorithm can be readily extended to common fractions, particularly if the first examples involve tenths. The algorithm is a simple extension. So this is the algorithm for fractions, which is very similar to the algorithm of addition. It is represented vertically. So here we have 5 and 7 tenths and 3 and 6 tenths. And we also have our model to work it out. So we add the 7 tenths to the 6 tenths, which gives us 13 tenths. However, that's more than a whole. So we will put the 1 up here, which makes the 5 6. And we will put the 3 down here, which makes it 3 tenths. And then we add 5 and 3, which is 8, plus 1, which is 9. So our answer is 9 and 3 tenths. However, students can visualise this using the model. With my model, I'm going to colour in what is needed. So here we have 7 tenths, plus another 6. So that's 7, 3, 4, 5 and 6, which gives us 13 tenths, plus all these which are wholes. 1, 2, 3, 4, 5, plus 3, which gives us 1, 2, 3, 4, 5, 6, 7, 8, 9 and 3 tenths. Once students understand how to add fractions with parts of 10, they can then move on to parts of 5. Here we have another algorithm, 4 and 3/5 and 3 and 4/5. So what we will do here is the same process. 3 plus 4 equals 7. However, 7 is more than a whole because it's out of 5 bits. Therefore, we will put the whole up here. And then the remaining is 2 pieces of the whole. So we have 2/5. Then we'll add 4 and 3 together as they are wholes, which equals 7. And then the 1, which equals 8. I am using a regional model of a rectangle because it's the easiest region to partition. According to Ray's, pictorial models can help children see that adding and subtracting fractions can solve problems similar to problems involving whole numbers, develop an idea of a reasonable answer, and see why a common denominator is necessary when adding or subtracting fractions with unlike denominators.
And what you want to call the whole is denominator. Now you're set to go. Numerator part, denominator whole.
Once students understand how to add fractions using the same denominator, they can then move on to adding fractions with unrelated denominators. A suggested way to learn this is through arrays. The misconceptions students may encounter are renaming fractions, difficulties with place value, equivalence is a reliance on the computational rules to rename, using the operations by not understanding and relating to equivalent fractions, not understanding the meaning of equivalence. Teachers treat addition without renaming as a separate introductory step. Difficulties with the concept usually occur because of a focus on the symbols and answer rather than the meaning, and they also might be confused which operation to use.
Parts of a pie, fractions, they're alright.